welcome to the San Francisco MySQL Meetup. We had that little rough start because we are again streaming and videotaping. So there are people who are, I hope, hi Theo, are you really watching live? So people have hit us up to watch when they can't get away from work. Sometimes people are across the country or the world, and then they can watch too. Or you can go back and watch it if you're unsure of what's going on. Tonight we have some great raffle prizes, as I hope you're all aware of. The Percona Live conference is coming up in 2 weeks-ish. And so, of course, like last month, we got raffle prizes, and I see some people who won last year here. But this year, our cool thing we're doing for the first time ever is Percona's giving us a full tutorial everything pass. And this is going to be interactive, so those watching live can do it. And those that are members of the meetup can do it. So what you need to do is, I sent out an email, so read your email. But basically what you need to do is tweet about the session, whether it's a tutorial or a talk or a birds of a feather or a lightning talk that you're excited about seeing. And then you have to have 2 hashtags, Percona Live and SFMySQL. And then tomorrow they'll draw, randomly, they'll draw a winner, and that person gets the full pass. But we also have 2 passes we're raffling off on your tickets. We have Blackbird donated a $100 Amazon gift card, and then AWS, Amazon, we have 2 $25 cards for AWS. I don't know if lithium's, nothing for lithium this month. But we have so much other stuff.
Ryan knows that.
And we have no t-shirts this month, but the conference is coming out, and you know it's hard not to get t-shirts, so I'll get a bunch of t-shirts and bring them here. Next month, of course, it is the recap of the conference like we do, so it generally tends to be a little more low-key, and we talk about, I guess hopefully Percona, maybe even you, are going to come, and they usually someone from Percona comes and talks about the conference, what was good, what was not. Maybe I'll do it, I don't know. But we always have that, the meetup after the conference. And then we have 2 other meetups. We're not sure which month they're going to be in. One is on Eclipse and Vert, and the other one is on Shard Query. If you want us to get a speaker, send me an email. The conference is coming up, and I'm really good at hunting people down. And outside of Facebook, I've been able to convince everybody to come talk to us. We haven't gotten Twitter here yet. But, yeah. So, does anybody have any announcements they'd like to make? Can you raise your hand and I'll run the mic over. Oh, I forgot our sponsors.
We're good.
Okay. All sponsors are hiring, and tonight we have Ryan Lowe doing my favorite talk on tools.
I've never seen this one.
You've done other tools talks.
You good? Can you hear me? No? Yes? All right. Good enough. So hi, my name is Ryan Lowe. I'm here to talk today about optimizing performance, choosing the right tool for the right job. I'm doing something a little bit new. I'm using my iPad as a presenter notes. And just tell me if it looks as awkward as I feel. It's sort of routine. Before I start, I actually do have an announcement. They mentioned the Percona Live conference, April 1st to the 4th. There's actually Open Source Appreciation Day on the 31st, which is the Monday. It's in the afternoon. There are 2 tracks, one dedicated to CentOS, one dedicated to OpenStack. So if either of those are in your critical path of your organization, it's free. I think it's limited to about 100 folks though. So go to perconalive.com and register if you want to go. So on the meetup, I think the invite actually said optimizing MySQL performance, as it was pointed out to me. And we actually took the MySQL out of it because the tools that are presented here are useful in almost every diagnostic situation, which is good for those folks on Postgres or anything like that. I suppose not maybe. So a quick poll. How many of you would describe yourselves as developers only? Sysadmins only? DBAs only? Some mixture of those 3? And that's about what I expected. Developers actually see the world through their own application. So when they start to see performance issues, they tend to instrument their code or use profiling tools to figure out which functions are being utilized the most and then go down the stack to eventually find what the problem is. Whereas the system administrators and the DBA types tend to look at the systems that they're administering, find the resource contention, and then work their way up the stack to solve those problems. And as a consultant, I tend to follow the sysadmin sort of point of view because it's really cost prohibitive for a consultant to go in and instrument and move code base. So that's what we're going to focus on today, sort of the system aspect. For those of you that actually aren't familiar with Perf, we do MySQL consulting support and remote DBA, and a lot of our times our consultants are asked to diagnose issues not just as relates to MySQL, but also other things like Linux or Apache, Redis, things like that. So these are basically the tools that we use. This is our agenda today. I'll try to keep the presentation short, around 40 minutes, so we have a lot of time at the end for questions. But please do feel free to interrupt me if you have any questions, if something's unclear, or if I start to ramble. This talk is really focused on the Linux environment, and we'll cover the most commonly available tools. It's not meant to be exhaustive. So we'll start quickly with what, why, and an overview of the resources that we care about, and spend the vast majority of the time on doing a deep dive into each of the tools. So the purpose of this talk, again, is to introduce the primary tools used for obtaining and collecting metrics and status information about system diagrams and system components. And that's really the purpose for investigating performance issues with MySQL. And there are four primary reasons to learn about system performance. And the fourth that we won't talk about today is just simple intellectual curiosity. So we all know that quick and consistent response times are really fundamental to all aspects of online businesses as well as offline businesses. Unfortunately, hardware seems to often shrink compared with our growing data sets. Applications have bugs and bad queries, and finding and fixing these performance issues are something that system administrators and DBAs have to do day in and day out. So having a method and knowing the tools that are available to you can prevent issues or lessen the time between when the problem manifests itself and the fix is reported, in time when that piece actually equals money. It also helps getting the most out of your hardware. You can extend your purchase lifetime and alleviate sort of your IT budget, and of course, again, that equals money. And furthermore, throwing hardware at the problem is not always a solution, or at least not always the best solution. Again, finally, the knowledge of your workload and its resource consumption is going to help you plan for growth. It should be noted that capacity planning is really a very complex topic, and that's the scope of today's talk. So, actually, another quick poll. Who here would describe themselves as the economist? 2, 3, all right. Fireman? Those. And then the architect? Oh, 4 architects than I expected. So all systems are composed of a few basic resources that we know about. CPU, memory, storage, networking components, and then caches, mutexes, buffers, basically virtual resources that are consumers of the hardware resources. And the hardware of our systems and algorithms, they do have limits, and it's something that we really need to learn and understand about each system before we deploy it to production. So as soon as you buy a new system or a new component of a system, it needs to be really thoroughly benchmarked so that you understand its limits and capabilities. And that's going to, of course, help you when you need to forecast how you're benchmarking our hardware. And Aaron can talk to you in depth about benchmarking these things. So when a performance problem arises, it must be one or more of these resources. And so the investigation should start with that. I personally, first, when I'm doing a performance audit, I do look at the hardware first to do basic sanity checks, like are there a number of threads running, is it swapping, is the disk full, and I do all this before I look into MySQL so that I have some idea what I'm going to look for when I go there. And oftentimes looking at the hardware resources first will lead me to the conclusion that MySQL is not in fact the problem. So the tools. Most of you should recognize these tools as part of your standard toolkit. They're included in most Linux distributions and really represent the bare minimum that you should have at your disposal. So let's just walk through these. Top, everybody should know top for general monitoring. vmstat, again for general monitoring. iostat for I/O, GDB for back traces and other black magic. oprofile, which is a system-wide profiler. strace, which profile system calls. netstat, ethtool, and tcpdump, all of which sort of go into the black magic of network. And then the component tool, the tool is pt-diskstats. It's a replacement or other augmentation for iostat. pt-ioprofile gives per process and per file IO statistics. And then pt-pmp is a performance profiler, or rather it's Percona's version of it, and it's a wrapper around GDB. And then pt-MySQL summary, which is a condensed MySQL summary. This second slide has all the Percona tools that we use, and they're basically when our consultants have found limitations or problems with the tools on this slide, we've gone to our internal developers and said, please make these tools that fix these other problems. So these tend to be the Percona consultants' go-to tools for what they do. But I won't spend a lot of time talking about that because the other tools should do most of what you need. And if you find that there's a problem, then that's what you should do.
You're missing dstat.
I'm not missing dstat. If I did a comprehensive list of these tools, there would be thousands of them, right? These are just the most common ones. Dstat, anybody love dstat? I got 2. So maybe next time. So you should read the man pages for all of the tools there because the command line options are different in all versions and in all distributions. For those of you that don't know Linux, BSDs and Solaris don't have the same tools available. And for those of you on Windows, I'm sorry, but this is not to talk for you because I don't know anything about Windows tools. There are really 3 times when you should be using these tools. One is when you first buy a system before it's ever deployed into production. Second, during normal operations when no problems are happening. I'll make these available afterwards. And third is when there's an actual problem happening. It's important to use them in each of these 3 contexts because when you're benchmarking a brand new system, you can use these tools and you can know its general capabilities. Again, that helps with forecasting. You should have these tools run when there's not a problem because it's against those measurements that you're going to compare the measurements that you get during an outage or during a problem time. For example, if you only use these tools when there's a problem or an outage, you may see that CPU is at 90%, and that might lead you down a rabbit hole where you spend an entire day investigating CPU counters and all these performance issues, only to find out that the system actually normally operates at 90%. Right? So it's important to do this early, do it often, especially with any major code changes or with any application upgrades like MySQL or any system upgrades. So before I go on, other than dstat, what do you guys feel that I'm missing? HTOP is nice. ATOP? HTOP. I think those might be on the list at the end of things that I'm not going to cover, but I'll add those to the list if I'm doing this presentation at Percona Lab in a couple of weeks as well, so ATOP and HTOP will probably
Use LSOF.
LSOF?
A lot.
Yeah, there are a great number of built-in tools. LSOF, PS is particularly powerful and it's sort of underappreciated. But yeah, it's definitely a great tool. So tool number 1 is top. I've chosen top as the number 1 tool because it's been included in standard Unix distributions since 1984. And in my opinion, it's probably one of the most underappreciated tools. Just take a look at the man page, you can see how powerful it is. Top is great for a quick view into how the load evolves. It's got 1, 10, 15-minute moving averages for load, and it tells you the trend is going up or down. And you can browse the processes to see who's using what. And it works based on a refresh, so if something, if you have a top refreshing at 1 second intervals, if something is faster than 1 second, then you won't see it in the process list, but you will see it as part of the average. So you'll see it's a flex. The first line is just a quick summary, right? It's got the uptime, users, and load average. And here we can see that the load average 15 minutes is 19, 5 minutes is 34, and 1 minute is 1.21. So we can see that the load is gradually trending up on this machine. And this is actually a great interview question. What does load average mean?
Number of processes ready to run, waiting for CPU.
Yes, it's the sum of the processes in the run queue and currently executing, right? And the number is an absolute number, so it's unbounded, unlike actual CPU utilization. So, yeah, I think there's a lot of misunderstanding around that. I'm not exactly sure why. But a quick digression, I'm often asked by customers, at what load average should we have logic support, right? And the typical answer that I hear for that is, whenever the load average meets or exceeds the number of CPUs in your system. So if you've got 16 cores, you should alert when the load average reaches 16. And that answer is sort of fine as far as it goes. Like, if you don't have any knowledge of the system, that's a good stock answer. But the real answer should be whenever the load average is about to exceed the level at which you no longer meet your SLA. Right? So you should have a formal SLA for your application, I imagine you all do. And you should have benchmarked so you know what load average is. So it could be 8 on a 16-core system, or it could be 64 on a 16-core system. So it's all application dependent. Second line, process summary, total running, sleeping, stop, zombies. Another great interview question. Orphan versus zombie processes. Anybody?
So I've been attached to a parrot, it's not control, just in your dead.
Yeah. So I think it's.
So we have a process that's spawned with children.
Yep. Yeah.
Or it's threaded going into the master that can't be. Linux thread is a process, right?
But you can see in PS some of these things as well. But I think those are two great interview questions that everybody should know if they don't.
Can you repeat his answer? Because we didn't hear.
That's great.
But for the video.
I tweeted at the video users. How many live watchers do you have? Can you stop?
2.
All right. See, they already answered. The third line is CPU user system. Nice. Idle, wait, hardware interrupts, and I think I'll go through all of these in just a minute. The fourth line shows memory, the total used, free, buffers, and the last line shows swap information, total used, free, So back to the third line. So user CPU time is CPU time that's spent running non-nice user processes. System time is what's been spent running the kernel and its processes. Nice is, of course, any time that's been spent running nice processes. And IO wait, right? This is where everybody in this room tends to focus, because we all deal with persistent data, so we all deal with disks, and disks are inherently slow, or at least they used to be. I'll tend to harp on this a little bit today, because it really is so important and it's such a common problem, but do remember that it's not always the problem with MySQL, especially with modern SSDs and PCIe cards. Here we go. Hardware interrupts, software interrupts, and steal time. Steal time is particularly interesting, and I think largely ignored by most folks. It's the amount of CPU time that is stolen in a virtualized environment. So whatever the hypervisor is taken away to do other tasks, like manage other virtual servers, right? And this is particularly interesting for those folks that are using virtualization like VMware or Stack, and also for AWS users. Right? AWS or EC2 instances do have this metric exposed, so you can actually keep an eye on this and see if you're getting your money's worth. And if you notice a very high steal time, then you probably just want to kill that instance and bring it home. Right? So that's an important metric for AWS users in particular. It's important to remember that these are system-wide CPU metrics. To dive into process-specific CPU, you want to use like strace, ltrace, oprofile, gprof, or something like that. And we'll dive into some of those. vmstat. So when I engage in a performance audit, typically vmstat is one of the first tools I use. It gives a very quick and compact summary about various system resources and their related performance problems. It reports statistics about kernel threads and await queues, memory usage, paging, disk, interrupt system calls, context switches, CPU. It's basically a dashboard of system health. It's something that you use to lead you in other directions. It's very rare that you use vmstat and actually diagnose the issue. So here's a call-like common thread. Right? Prox R is the average number of runnable kernel threads. So meaning threads that are ready to run or already. And then B is the average number of kernel threads that are placed in the VM queue, basically waiting on some resource for IO. Under memory, swap virtual memory used, idle memory, buffers, cache, and you can actually see inactive versus active memory with some command like applying. I think it's a dash A, but it's not shown here. And then under swap in and swap out. This is, again, arguably the most important part of vmstat. So swap in is the amount of memory swapped in from disk, and this is bad. It's actually very, very bad. Page in operation occurs when the server is experiencing a shortage of memory. So while all virtual memory servers will page out to the swap disk, page in operations indicate the server has exceeded the available memory. So any non-zero value for SI is going to be problematic, right? It means that the contents of memory are read in from the swap disk, which is
So are these swapping in or paging in?
swap in, swap in.
Well, swap in says you swap a process, you swap the whole process. Whereas paging memory, you don't page memory.
I will check.
Swapping is really, really bad.
Yes, it is. And
Paging is bad.
yeah, this is really bad. As far as I understand, this refers to swap in, and it's of course very bad. Swap out, of course, is the amount of memory swapped to disk, and this might be unnecessary. So it's less important to swap out. Just check your vm.swapping slide. It should generally be 0. To recap, again, swap in is very bad. And to be clear, you should really ignore the very first line here, because oftentimes you'll see swap in of non-zero because it's got some past historic performance problem. So there are things that you really want to care about here. Everything after the first line, the refresher. Under I/O, we have disk reads and disk writes. And this can be actually a very interesting indicator to see if your interleaving buffer pool is properly sized. If you've got a lot of disk reads, it can mean that the hot data set doesn't fit into memory. So again, if you've got a lot of disk reads, you might want to add more RAM or increase the interleaving buffer pool size. Under systems, we have interrupts for a second and context switches. And just to explain what a context switch is, when the CPU is running a thread, and that thread has depleted the time that the CPU has allocated for it to run, the CPU needs to store that context and load the context of another thread. And so that's what we mean by a context switch. And my experience, in sort of a hand-wavy general way, is when you start seeing 50 or 60,000 per second, it's already quite a bit, and it gives us a hint that there may be mutex contention or too many running threads. Of course, that is a gross overgeneralization when you benchmark your system when you first got it, and look at your non-problematic running time, you should see what's problematic and causes it to misread slow. So high context switching rates isn't necessarily bad, but it may lead you to the possibility that more CPU time is being used to handle threads than execute thread commands. So if you're familiar with the query file in MySQL, oftentimes when you get hundreds or thousands of queries that all stuck, if you look at the context switches, you'll see those spiking as well. So there's a very high correlation. CPU, it's got sort of the same things we saw on top, so I'll go quick. If we see a high user time, we know that there's likely some contention of some sort in MySQL, it's a MySQL specific box. High system time usually indicates that there's some slow resource or contention for a slow resource, or inefficient polling subroutine, or poor malloc implementation or something of that nature. Idle time, we generally don't care about. Wait time, waiting for I/O, which we talked about, and steal time. Right? So I'll talk again about high I/O wait times. Lots of folks assume that when you've got high I/O wait times, that the solution is just buy Fusion I/O and call it a day, right? And don't get me wrong, I love Fusion I/O, and they love me. I've spent hundreds of thousands of dollars with their company over the years buying Fusion I/O cards. But in reality, high I/O wait can be caused by a number of things. First is poor application architecture. If you've got a lot of static objects like user data that don't change a lot, put memcached in front and just don't compete for the limited database resources. Can be poorly written queries, right? If you've got bad where clauses, or if you've got joins and up using indexes, then you can be reading a lot more data from disk than would otherwise be necessary. And then a poorly tuned MySQL, right? If your buffer pool size is too small, then you can be reading all the data from disk that you need. If your backseat table size and temp table size are too small, then you can be writing to disk more often. So I've seen countless times where something as simple as tuning line.conf or doing a periodic can get this to near zero, get the IO wait time to near zero, and eliminate performance problems. And the final thing is insufficient memory. This really goes hand in hand with improperly sized humidity buffer pools. If you've got 32, if your hot data set is 32 gigs, and you've only got 16 gigs of RAM, adding another 16 gigs to your buffer pool might be a very simple solution to the problem. So iostat, of course, is
So like that, the systems have so much memory, let's say 120 gigs of RAM. And if something is reading it, where would it show under system utilization or under like if you're reading from RAM?
if I'm reading from memory,
Yeah, directly.
then we'll just see sort of memory usage, right?
But would it show like under CPU usage, or like sometimes you have systems that are not showing nothing on the way on disks, but it's doing something, but it's kind of hard to see. It seems like it's doing read from RAM or loading data there or processing.
Yeah, generally speaking, if it's reading from memory, I mean, it's not going to really show up as anything on the CPU time. But in that case, you'll probably want to get something more process specific rather than global metrics like vmstat. Like if you GDB it or oprofile it, the process, then you can see exactly what it's doing.
So I won't see from here when it's reading from RAM.
I mean, not really, not if it's waiting for IO, or not if it's not waiting for IO.
It's just the subsystem, like the RAM is cheap. 256 is not. It used to be a rare thing, but not.
Yeah, no, I mean, for Kona, we're given hardware all the time to benchmark, and we've got Cisco systems with 2 terabytes of memory, and for me, yeah, 128, 256 gigs is very much the world of commodity these days. But if somebody's on AWS, I don't even know if you can get 256 gigs of RAM on an AWS instance, right? Or some people, they purchase hardware every 8 years and they've got what they've got, or they just think it's too much money. Or there are any number of reasons why people don't have that kind of hardware. I find it difficult to justify personally, but again, in the role of a consultant, I'm sort of given this. I have this old OS2 work machine that I've allocated, and it's yeah. iostat. So this is the tool we use if we think the problem is IO related. The tool is ubiquitous, and that sort of makes it a top favorite, even though I personally prefer the Perf toolkit pt-diskstats tools in its place. I tend to use iostat if, again, vmstat on top is giving me any indication that it's IO, and it will only show the extended device report, which I think is the most interesting. So we'll walk through this. I mean, how many of you have read the man page for iostat and understand each of these columns? Right? And I think this is a perennial problem. Most people have some understanding of what some or most of these columns mean, but it's rare that people understand all of them. And I think especially in the case with iostat, it's important that you do, because there are 2 columns here that should always be ignored. What are they? Nobody? Service time is always wrong. It says so in the man page. It's always wrong, and it's slated to be deprecated. Percent utilization is only accurate if you're using a single spinning disk. Right? So you should always ignore those columns. And a lot of folks, oh my God, it's 100% according to iostat. Well, it's not a real thing, right? You need to ignore that. So knowing these tools is as much about knowing how to interpret them as actually coding.
Ryan, you said percentage utilization is only accurate if what? If you're only using
It's 2013. It's not accurate. Just ignore it. If I were in charge of the world, we don't. Right? Just always. It's basically like 1 speed. Right? That's what it's accurate to. So if you've got read 10 with 8 disks, then this is very, very much not accurate. If you've got a mirror of 2 disks, it's maybe directionally correct. Questions, comments, concerns? More right away? So here we have the number of already merged requests, and these are completed to a device. So this is the number of IOPS basically that your storage system has delivered, which it's important to sum these up because then you can tell how close you are to the maximum theoretical IOPS of your iostat system. And we're not talking about it anywhere in this presentation, but it's really important to know how to accurately figure out how many IOPS are available to you, right? So if you're using a SAN, a lot of times you talk to the vendor and they'll say, well, you can have 40 infinity IOPS. So we've got a magic caching there. And that's not a real thing. And you can determine this by benchmarking systems. And there are some mathematical equations that you can use based on the number of disks, the speed, latency, the seat time, all that jazz. So unbelievable. This is the data per second expressed in watts, so 512 bytes. And let's see. Average request size, average queue size, and this should trend towards 0. Right? Anytime you see an increase in the queue size, it's going to be indicating that there's either a bottleneck or there's just too much concurrency going on. So typically, if you see the queue size growing, you're going to want to add more disks to your array to add greater parallelization. And then the await, it's the time spent in milliseconds for I/O requests issued to the device to the server. So this is including queue time and service time. Again, service time, always wrong. Set utilization, ignore it. All right, oprofile. Before we go on, questions? All right, so we're moving to sort of process specific stuff at this point. The last tool was I/O, and this is much more CPU profiles. So the previous three tools were also very general. This is process specific. So what it means is that by the time we use oprofile, we will have made an intelligent decision about what we think the actual problem is. And on a host with only MySQL running, the cron jobs don't back up to other software, MySQL is probably the problem. If you're sharing an application server with your database server, then you need to sort of make an intelligent decision. Because if you oprofile something, you're going to spend a lot of time figuring out what it means and going through the output, and it could be a huge waste of your time. So here we have a basic set of commands that get you going with oprofile, and won't read this because you can just Google it online. But basically, you need to prepare your system for the profile, initialize it, start it, and by that time, it's running and deploying the data. So at that point, we expect that either you're doing this at a period of no issues on the system, just to get a benchmark, or you're expecting the problem to happen soon, or the problem's actually happening, because that way you get a trace of exactly what's going on. So here we have the code to dump the report and then terminate the thing out. This is the interesting stuff, right? So the report is going to look something like this. How many times the function was seen, the percent of CPU time, image name, and symbol name. And with this information, we basically have three paths to go. One is you can get the source code from MySQL, spill through it, figure out what my hash source symbol is, figure out why there's a bottleneck, fix it, put it back upstream, and hopefully get it in your version. Or you can hire a company like Percona to say, this is why it's there, this is the problem, this is the fix, and this is why you should care. Or, again, you can consult Uncle Luke. So my hash source symbol is the number one resource consumer here, 26.7%. So if we theoretically eliminated my hash source symbol from the equation, we've got a free 25% theoretical capacity on this box. Right? 25%. That's one.
26.7% of what?
The CPU time used in of the process that was used. So if you do this for 5 minutes and MySQL is using 100% of the CPU, then we could eliminate my hash source symbol and it would go down to 75%. Or thereabouts. Or you would get 25% more concurrency or some combination there. Right? And to go back, how many people know what this is? So, most people don't know, and most people shouldn't care. right? Because Uncle Google knows Uncle Google cares. And I did a quick search on this, and this was done doing a MySQL 5.5 benchmark. And about 30 seconds into Google searching, I found, oh, MySQL 5.6 has release notes that say, this is a problem, and there is a fix. So we upgraded to MySQL 5.6, we ran benchmarks, and my actual symbol was out of the top resource list, right? So you don't necessarily have to understand what everything here is, because you can just go search for it, right? And if you can't find anything,
How do I know what's supposed to be there now? Something is supposed to be consuming resources.
right, so what are the 3 times that you're going to use oprofile? When you first get the box on your benchmarks, when there's a problem when there's no problem, and then when there is a problem. So right here, like if this were a problem period, I would compare it against whatever I saw during the non-problematic period. And during the non-problematic period, let's pretend that it was no VM Linux and pt-ioprofile. Those were the top 2, right? So we should be able to sort of at a glance see what the difference is. We might not know what it means, but other folks can know what it means, or we can then do our research, right? It's much easier if you have something to compare it to, because if you don't know, like you're just sort of guessing on the dark.
So oprofile is intrusive or not?
It probably won't crash MySQL, but it will affect the overall
When you run
performance.
it on a production server?
If I've exhausted most other, it is invasive. It's probably actually, a lot of folks will say it definitely will, but I'm not really a definite guy. More of a problem with the production system. So I don't do this on customer systems unless it's an emergency and they're losing money, right? If they're already losing money, then there's like doing this is
So
going to
you
happen.
want me to go about running just in case.
No, this is,
It's expensive.
yeah, it does affect the overall performance of the system. And most of the times when you have a problem, or when oprofile causes a problem, it's because you're so close to the limit of the resources on the system that this extra resources that oprofile is using just causes it to ego to the edge. Right? It generally doesn't crash. It's not like GDB where I assume it's going to crash. Right? So
It shows just library context.
yeah, and there are 1,000 command line options. I know very few of them. So read the man pages and you can get very different results.
So you have no profile for the process, right?
Yes.
Is that which?
And
I think it was the other page.
That's
which
one.
was-
And that also, that won't affect child processes or something, correct?
It will try everything.
Basically, hooks on Cisco protocols and allows you to cycle. That's where the other
So oprofile is one of the less intrusive invasive tools, or less invasive invasive tools. So I run oprofile before I. Oh, and GDB. So GDB, of course, is the new debugger. It allows you to do all sorts of magical stuff, including the one that interests us, which is getting full back traces from all the MySQL threads. And we'll see some neat tricks as well, and I'll show you how to do this. A caveat is that GDB is very intimidating, right? The syntax is arcane, interpreting results is a huge thing, shall we say. And most of you, again, should assume that GDB is going to crash MySQL. So I typically run this during benchmarks or on non-production machines, unless I've totally exhausted every other option. I can't figure out what's going on in the production machine. And if crashing is the way to fix the problem or figure out what the problem is, and so this is a backtrace of the chain of function call to get the to start a slave thread. So this is more just as an information on how to read, and you read it from bottom to top. So most of you who are familiar with MySQL replication will recognize our thread -0, execute the relay log, next event, wait for update, things like that. So it's read bottom to top. And again, this is one of those things that it just takes a lot of time. There's a huge learning curve. And this is in particular interesting. I just want to show how to read it. So these are the commands you can use to get back traces with GDB. And you can get regular or full, and there's dozens, if not hundreds of tutorials of GDB online. To become an expert in GDB takes a long time, right? And it takes a long time as a C++ programmer to really appreciate the power of it. Every year for the MySQL conference, I actually submit a talk that's called, hey, watch this, the GDB and MySQL list. And every year it gets rejected. But I really think that GDB is underappreciated and undervalued in the MySQL community. I think we do ourselves a disservice by not using it more often. So GDB allows you to attach to running code and poke around, add breakpoints, run errors, and things like that. Anything for the feature debugger. So this is the output. Format profiler, which is basically a set of knock strips on GDB output to make it more readable. Again, I won't go through this because this is actually not super interesting. It's hard to find something that's interesting, but most of these things are quick Google search. This is why I love GDB, because you can attach to a running process and do very, very scary things. So I assume you've all encountered there are too many connections, right? You're getting an error in your application, and you can't log in, you can't figure out what's wrong because you can't see. So you can use GDB to attach to MySQL and set the max connections to something arbitrarily high. And at that point, you can then log into MySQL and figure out the problem, or at least get a snapshot so that you can see. And this is what MySQL performance block, I guess that was so much fun. And also, like, if you've ever seen your MySQL error log filled with, oh, your LSN is in the future, right? GDB. And there's a lot more to that as well. Domas from Facebook, I wish you would get to talk. Get him to talk for an hour about GDB.
Right.
Look at his blog. It's got a whole lot of fun tricks. I mean, you can spend an afternoon just reading them, laughing and trying. They're super useful. Did anyone here actively use GDB? One? I haven't touched the stars content. But yeah, GDB, I mean, everybody should take a few minutes and look around and just understand through what it is. So strace is something that we use to trace high CPU utilization in a variety of other sort of erratic performance problems. So like oprofile, this is it attaches to a process until it's either killed or until the process ends. And it shows the system calls that command runs and the signals which are received by the process. So here's the sort of standard way that we invoke strace, right? Follow the forks, collect statistics, sort by time, and attach to MySQL. You'll see that it sorts by time, and most of the time when you look at a system, you want to sort by aggregate time. Because if we eliminate this syscall, we eliminate 84% of the time usage. So all of a sudden we've got free users. It's pretty neat. And so, so this is one way to invoke strace. Another way is just almost the same thing, except instead of aggregating, it actually gives you timing information for when things are called. And this is especially useful when you've got something that stalls, right? So if you've got some particular process that just never finishes, or MySQL tends to be stalling here and there, like it'll actually give you step by step what happens until it stops, right? So I have actually no idea what we were doing during this benchmark. But it's tedious to read, but once you just go through it, it's also produces a very large volume of output. So you want to put it into a file and explore it later. And one fun thing that my coworker came up with, a nice use for strace is to see which configuration files are being read. And for those of you that are consultants or like log into systems that you've never seen before, there can often be like some very confusing daisy chain path of configuration files that you know. So you can strace MySQL and just see what grep.my.conf, right? And so we can see that that's my.conf, that's MySQL.my.conf, hold.my.conf. Those are all the things that are being read. So it's really interesting systems that you don't have control over or have to manage.
And will it crash? I mean, I had strace crash my MySQL daemon because it was in a weird state caused by another process.
So it can crash, but oprofile probably won't, strace can if you will. And I know. other people will say GPD won't necessarily crash, but in my world, it's a safe bet. But don't do it unless you're ready for a crash. This trace, I don't do it in production unless you've already exhausted everything else. But, it's point toss.
It crashed, we never got any on, but it did point that it wasn't my sequence process. So that was not.
So then it was working.
Yeah, it's a data warehouse, so it's not.
Yeah, I mean, I
Yeah.
tend to say that we'll crash the process, or, DBD will, or S-trace complaints. So you don't do them on customer-facing systems, generally, or systems that you can't have done. If you're processing financial transactions, certainly don't use these things there. Data warehouse.
Until you quit.
Yeah, do it on your last day. Right? Perf. So I think I actually omitted this from the original slide because perf is not a tool that I use very often, but I did a little poll with a consulting team, and it turns out that a whole lot of people actually know and love and use perf every day. So I thought we'd include it here. And some slides ago we saw the output of oprofile. That allows us to perform system-wide function called profile. And oprofile was the profiling tool of choice until a few years ago, for about a decade. And then some kernel developers said, okay, well, we're going to make a formal API for performance statistics counters. And then they did that, and then the tool that they released as sort of a proof of concept was perf. And perf has grown and grown over the last few years into something that's very mature, and a lot of folks use, and a lot of folks say that this really deprecates our profile, but I'm old and can't learn new things, so the profile is still there. Perf is very flexible. Right? It can be used in a system-wide manner, and here we're emulating top. Right? So you can emulate top with perf. So this is the idea here is that perf can deprecate many other tools. And then in this slide, this essentially replaces the output of profile. It's got basically a very similar colorized, more modern, consider this more modern output of profile. So you can see here, SRE log, timeout thread, it's 6.3. So you can get the same sort of reports using perf as you can with other tools. But perf, with all that flexibility, of course, comes sort of complexity in using it. Right? You have to understand all the command line options, their ramifications. Some aspects of it are more invasive than others, some are not. You just need to sort of read the tool number 8 is netstat. And honestly, the previous 7 tools, you sort of can only scratch the surface, and I'll have a list of another 20 tools at the end of the talk that a lot of people use. But I want to give the last 3 tools to talk about that. And networking, most of us, I don't think any of us would identify as a network engineer, but network engineers tend not to get involved unless you can absolutely prove it's the network. Right? So it's often on us to say, see, it's the network. And only once you get that proof will somebody who's competent come in and do something. Netstat is a great tool. You can basically invoke it in 5 ways. You can see network connections, routing tables, interface statistics, masquerade connections, and multi-pass partnerships. It helps diagnose the connection timeouts, what ports are open, and what IP is bound to what. So here we have a very simple command. So it's just a list of active and established connections. And you can use this command to see who's connected to MySQL, which can be particularly interesting. You spin up a new application server, and all of a sudden there are a lot of problems. Maybe that application server's gone crazy, or the thread pooling is not configured the same as the other host. So if you can aggregate it and sort of grab and figure out who has the most connections, who's using the most. So this slide actually might have been earlier in the presentation if we were going by the amount of times I execute this command. Right? So netstat, I understand very little. Very little. But I know netstat will show me a lot of interesting things, like failed connection attempts, or connection resets, or connections dropped, right? So I know based on the netstat that I've done periodically and graphed over time what my rate of normalcy is. right? And then if I see a huge spike in drops because of missing routes, then I know that I can say to my network guy, hey, what's a missing route, right? Or whatever. So I use this all the time, and not that I have to understand what it means, I just have to understand how it relates to the baseline that I collected previously.
So, my assessment is per protocol systems.
I mean, it's,
So again, with netstat, you want to do that, first look at your box, and then under all the circumstances, then if anything deviation, then you call it down to the box. Here's my normal profile, here's what it's doing.
well, so I'm sort of giving this talk right? In an ideal world, we've got cacti or whatever people are using these days to graph all these things. So we should have a graph of the number of drop connections because of this difference, right? And we should see that it spikes. So that should be enough. We can say, hey, never graph with this spike. But in the absence of having graphed those things over time, we have to compare this connect to the end of the ring before. So yeah, I mean, ideally you're going to have some holistic monitoring graphing solution. It'll give you all these things. Yeah.
I imagine you can build your own dashboards to periodically do a lot of this monitoring and memory tools like Nagios and cacti and stuff, so maybe at the end, also.
Yeah, I'll do that now. Anytime you say roll your own bash script, it's 2013, somebody else has done it, right? And so
You
it's-
can recommend something.
yeah, so for a lot of these things, like it really depends on what you're using. So for cacti, I know that Percona has the Percona monitoring plugins, which are just a suite of PHP and Perl scripts that collect data and ship it back to the cacti server. You can use collectd, to give these things and ship it to Graphite, or basically there are Zabbix. What else is there?
Datadog.
Datadog. I don't know what that is, but I assume it's some graphic.
For training, that's pretty cool.
Yeah, so there's. Oh,
Afford it.
if you can afford it, but most of us can't afford it. I talked to somebody else.
Datadog is awesome though.
So yeah, these can and should be graphed, and whatever system you're using for graphing generally has some open source. Like Nagios has Nagios Exchange, Cacti has some Cacti forums, and people share the scripts that they use. And sometimes the scripts are of dubious quality, but generally speaking, if you have to roll your own, you can. But these graphing systems have existed for years, and people have had plugins for them for years. So certainly do that. What graphing system are you using?
I'm using Nagios, just out of the box.
So Nagios can graph, but it doesn't do it particularly well. So most people use Cacti alongside Nagios or Graphite alongside Nagios. So I would definitely look at stats team or collectd or one of these that people use to sort of aggregate these things. Or just look at the open source Nagios plugins for graphing, or the Nagios scripts for graphing new stuff, and then you can base your own scripts on those and feed them to whatever system you use.
And then there's that open, the competitor of Graphite, we've had the top.
OpenTSDB?
Yeah,
Yes, there is.
there's that.
So maybe I can say, I can monitor my apps, I haven't been running servers to maximum capacity, scaling massively, maximum, so I've been relying on reliability and proprietary systems. So maybe this talk tonight was not only need to compete and set up better systems, so when I have something that's failed, it's overloaded, that's not running.
Yeah,
Some
so
that work for people, and they have dedicated people to do all this stuff. Now I want one of that stuff.
yeah, and to be honest, most people start with Nagios and Cacti just because they're solid. Right? Everybody eventually moves to something else, but that's where everybody starts. And if you're not growing exponentially, then odds are those two things will serve you for a while.
It'd be good to learn more about this preemptive, right? The whole thing about monitoring is the learning, you want to catch it before it goes out.
Yeah, absolutely. And earlier I mentioned the load average, right? And this is how you set your thresholds. You can use these tools that'll learn what your thresholds are. But yeah, Aaron, you should find somebody to talk about monitoring solutions, like just an overview of landscape. Monitoring and tracking.
meeting?
So I find ethtool to be sort of a complementary tool to netstat. So netstat is more focused on the connections, running tables, things like that. Ethtool gives me a much more hardware-centric view of the world. So here, this slide probably doesn't do it justice. We can get detailed information about link speed, duplex configuration. It's also one of those tools that I use all the time to just basically look and see if anything's out of order. Almost all modern Ethernet cards can be configured to understand 100,000, right? And since that is a configuration setting, you would probably be really surprised how many people have these configured at half duplex 10 Mbps. Right? And it's just an oversight. So you do it once on your systems, but I have to do it all the time on the building systems because I don't know. But ethtool is, it's a very simple tool, but it takes 2 seconds to run, and you can often find things like, why is this not pulled in place? TCP. Venerable TCP. IFT. TCP was first included in the T7 standard Unix distributions, and it hasn't changed much since then. So if you love command line interfaces back in the 80s, you love TCP. It's very powerful, but generally gives arcane and hard to read results. It's one of those things that when you see somebody use TCP enough, you just kind of stare and wow, this guy clearly knows what's up, right? Like, can everybody tell what's going on here? It takes some time to get used to. Well, there's actually it runs an output through strings. You can do a lot of neat things like strings. But it's a special kind of person who uses TCP in advance way. I tend to use it in a very simple way. But there are great things that you can do. You can capture packets from an interface, from a host to a port or to any target protocol, or filter packets. So in this case, what I usually do is say, all right, show me all the traffic that's going to or from MySQL. And with enough time and patience, you can actually look at the traffic flow. You can see the select word, and you can actually see the results. It's again not the prettiest of formats, but there are ways that you can interpret it, read it, get the results really quickly. So you can determine traffic volumes. You can read non-encrypted traffic, which is always fun if you're sort of experimenting on the security side of the world. You can use TCP up to generate a slow query report, and you do that through the pt-query digest, which is a tool that Aaron loves. So I think the most useful thing that I've ever done with TCP was we had a Redis problem. And we didn't know what the problem was, we just knew that Redis was the problem. So after exhausting almost everything else, said, all right, we're going to TCP up it. And what we found was that simply by looking at a single command and looking at the traffic volume, what we thought was supposed to be a get of one single key value pair that was supposed to be about this big, it was getting 5 megs each time. This was being called hundreds of thousands of times. So we found that there was a bug in the code that instead of replacing, it was just a number. So TCP up for me, that's probably the most useful time, most useful it's ever been in my life. But if you spend a lot of time in one way, it's very powerful. So again, this talk is really only scratched the surface. Oh my goodness, 25 minutes over our time. Sorry. So more tool system tap, message, unit control, BKL trace, ping, dstat, SAR, IP, htop, atop, DF, uptime, pstat, instat, trace, laptop, instat. There are so many of these tools.
SAR is interesting because it allows you to go back.
Yes. Well, yeah.
And I
So
think that's one of the few tools
yes, SAR will allow you to do a whole lot of interesting things back in time. I tend not to use it because the systems that if I'm going to set up SAR, I'm rather just going to set it to graph, right?
If you had an outage, you try to figure out what the outage was. So you're trying to go back to the history to see.
Yeah, if SAR was wrong.
Right.
Yeah. So SAR is needed that way because it keeps on disk the log, and there are tools that you can use to parse those and make them much more readable. So it is very powerful, and a lot of folks like it. It's not one of my personal go-to tools, but
If I'm trying to solve a problem right now, it's not necessarily the best.
Yeah.
You go back and see, and it's not, I mean, it's not perfect, but it allows you to see a number of parameters in the system at that time.
Yes, and that's one of the most difficult things to do is have a problem happen yesterday when you were on vacation, and you just have no idea, right? Unless you did something like SAR, or you set up a stock and collect, you just have no idea what happened. So you either guess what it was, or hope that it happens again when you're
Is Luma control making that fire rate in Luma?
Yes,
So
or at least that's what we got on it.
So it's not for
Yeah, not for every system. All right, I apologize. It was a long meeting. Anybody have any questions, comments, concerns? All right, it's time to wrap.
Really? No questions?
So the person who was talking about how they didn't have monitoring, I turn on SAR when I first go to any job and they don't have monitoring on. Just easy to use it. You can go back and start graphing stuff while you wait for the person who's supposed to install monitoring. I do not know why this is so hard to install monitoring, and I usually will beg my boss, just let me install it, just let me install it. So while I'm waiting for the person who's supposed to figure out what to install and do all the research, I always turn SAR on. So there's always going to be a problem. And so then I can go back and use SAR. And I use dstat a lot.
Okay. Yeah.
There's a MySQL plugin that's broken, but
Fixing it?
I have no idea. I can't apply it.
So SAR is supposed to be a favorite, so it should take time.
It's just old school Unix. I think it's been around forever.
But I think if you install, when you install on Red Hat, CentOS, it's the systat package. It's the possibility you install iostat, you want to get it with SAR, which they just adjust the count tab and how you want the statistic this for the transfer. Good, default is 10 minutes.
Yeah, 10 minutes is a long time.
Yeah, Google helps you to figure out.
Yeah,
all
you could
that
just,
shit.
like, once it's already just an RPM package.
Yeah.
But a team star feels very old school because I used to be somewhere else.
All right, how about-
How come you didn't go over the Percona tools?
I'm 25 minutes over where I was supposed to be. Sorry. Next time. In the
There's
perfect
the next
time.
one, yeah?
Another collection tool documented on your website?
Yes, I would say that they're among the best documented.
There you go.
I think actually, Ryan, next time we need Percona tools for the cloud.
For the cloud?
The ones which were released.
Oh, the PCT stuff. Yeah, that's pretty neat. Actually, we could try this.
I downloaded it. read some documentation. But I haven't.
So here's a question. How do you monitor something that is able to use RDS?
So RDS is fun. So RDS, you typically use,
Stone.
yeah, you can use CloudWatch, which provides a very limited set of metrics. The other thing is you can actually use Nagios or Cacti or Graphite or anything to connect to it, because basically all you're doing is connecting to MySQL, saying show engineering status, show the process list, show global variables and show the status, and then you put those into some other system. You of course can't get like steal time or anything like that, CPU, but you get what you can. I mean, it doesn't expose a lot in terms of CloudWatch, but you can get all the regular MySQL metrics.
And CloudWatch has some stuff that's only available for API.
So they have some metrics.
Yeah, they have
Yeah.
metrics.
You can measure IO throughput,
Yeah.
those kind of things, but most of the time it's like.
Yeah, the RDS stuff is hard, right? Because the trade-off you're making is I don't want to administer the system, right? So that we're only given a limited amount of stuff to take care about the system. Just use a multi-AZ deployment and magic happen.
And they say with the new PyOps it's better, but still I would only use it for dev.
Well, it depends on sort of what you want to spend. I did an RDS talk a couple months back here. It's been about $2,000 over the course of a couple weeks doing benchmarks, so really expensive.
Any more questions? So you're all here for the raffle, huh?
That's right.
Thank you, Ryan.